Hello, welcome to the course of distributed antenna system. So today we are going to discuss about in-building distributed antenna system. So here in this chapter we are going to discuss about what is in-building distributed antenna system. Then we will discuss about the need for in-building DAS, then in-building DAS component, DAS implementation and the DAS design process. So here let's discuss about the in-building DAS. So here, as we know that the RF in building coverage become a fast growing market in recent years. So here the commercial wireless user increasingly demand reliable communication inside their offices and residential buildings for their business and the personal need. So here the local municipalities have issued ordinance to ensure the construction of new buildings which include adequate radio coverage of public safety signal. So here initiative at National Fire Protection Association NFPA and the International Code Council ICC make efforts to develop and implement national level model codes for public safety in building communication. So here the need for in-building DAS is like the need for the in-building DAS arises because of the increasing demand of continuous coverage, because of the indoor activities that generate the high traffic, due to the poor indoor coverage provided by the outdoor sites, and due to the offloading of the outdoor cells with the high utilization, and for the improvement of the network performance, there is a need for providing a in-building distributed antenna system. The next is in-building DAS component. So here the typical in-building coverage system consists of two major components. The first one is a bidirectional amplifier and the second one is a network to distribute the signal. So here the bidirectional amplifier or the signal booster relying and amplifying the RF signal between the remote base station and the mobile station. Whereas a network to distribute the signal in the desired coverage area. Here the most common type of distribution network is the system of coaxial cable and the indoor antennas, which is known as the distributed antenna system. So these are the two components that are required for installing a in-building DAS. DAS implementation include connecting all the cables and antenna throughout the building and balancing the signal level at each distributed antenna system node. So here an improper design DAS result in degraded performance and unnecessary cost increase. So here the DAS design process have a two-step. The first one is the first step of DAS design is to obtain an accurate and up-to-date blueprint of the building, and here that means an architectural drawing is the best here. And the second step is to get relevant physical information related to the building and the DAS installation, like what kind of material was used for exterior construction, what kind of material was used for interior construction, drywall or the concrete, is the building designed for a special application that may result in RF blockage, like are there any restriction on the cable runs and the antenna installation, where will the head-end booster be located, and answer to these all questions will have a great impact on the coverage area that is provided by the DAS nodes. So these are the two steps for designing a process, that is DAS design process. Next is in DAS system, radiated cables are used. So here it is a coaxial cable with lot of tiny slit cuts along the length of the cable. So each slit function as a tiny antenna with RF energy leaking out of it. So here the signal level coming out of the radiating cables are pretty low. So the coverage area is typically no more than 20 to 30 feet on either side of the cable. So here this cable is better suited for the areas that are long and narrow, such as tunnels or the long hallway. So it is also known as the leaky cables. Then mapping out DAS nodes, that means the location of the antenna. So an omnidirectional indoor antenna is used here in the in-building DAS. So here it has a 0 dB of gain which cover an area. So here 100 to 150 feet radius is covered by the omnidirectional indoor antenna at 800 MHz. 200 to 250 feet radius is covered at ultra high frequency, and 300 to 400 feet radius is covered at very high frequency. So this is about the in-building distributed antenna system. So this is all about the in-building distributed antenna system. Thank you.